And then when you're writing about these things afterwards, make sure that you are precise about what you do. If they're asking you to draw a conclusion, this is a particular instruction. It's not enough just to write about observations. You can't just say one of the spots travelled further than the other, or one of them travelled the same distance as the other. You need to say this means that it contains the same as something else. You need to draw a conclusion from it. Same with describing graphs. Make sure that you describe not just the shape of the graph, but also what it represents, if that's what they've asked you to do. So it's not just the gradient getting steeper with a higher temperature. It means that the rate of reaction is increasing, or whatever it is they're asking you to show. With these things in general, remember the rules. So with mean values, you need to remove any anomalous results. If they're pointing out anomalies, there's a reason for it. Remove it before you calculate the mean. But remember, this is one of the ways that we can make things more accurate, by repeating them and calculating a mean. And also, when you've done a calculation, is it realistic? Have you got a mass of thousands of grams for one atom? If you're calculating a yield, is it greater than 100%? It shouldn't be, should it? There are some things here. Do pause this and have a look at all these calculations you've got to be able to do. And then just a quick summary of the energy. So think about exothermic, endothermic and reversible reactions. Think about energy profiles and the colour changes here. Actually, these energy profiles come into C3. Make sure you know things like combustion must be exothermic because it's giving out energy and so on, whereas we've got some examples of endothermic reactions here. So do pause and have a look at this. And then finally, make sure you're happy with all the types of bonding here. We've got covalent compounds here. Now they can either be simple molecules, so they'll have low boiling and melting points, or we could have these giant covalent structures which are harder. Graphite is a covalent compound that conducts electricity. Remember, this time it is the electrons that are free to move, but they move throughout the molecule, throughout the structure. Diamond, on the other hand, no free electrons, nothing there available to conduct. And think about nanotubes. Silica is the other example that we use of a giant covalent, and so on. Also, this is about metals here and structure and bonding. Make sure you talk about ions in metals. So if we're talking about metals here, remember it's a giant structure, it's lattice, it's layers, it's made up of ions, it has delocalized electrons, and the electrons can move and they can flow through the metal. This phase here, through the metal, is really important. When you're talking about the structure and bonding of an ionic compound, if they're talking about structure and bonding, they're not asking you here about how the electrons are lost and gained. They're talking about the structure once it is formed. We're talking here about lattice or giant structures. It contains ions, Na plus and Cl minus. There's an electrostatic attraction between these ions. And remember, the ions are not free to move unless they are melted or they're dissolved. And also, because of this lattice structure, they have a high melting and boiling point. Again, it's the language, but when you're talking about the rate of reaction and talking about the fact that there are more collisions, which is why something speeds up, it's not just that there are more collisions, it's the rate, it's that there are more collisions in a certain time. So it's actually the frequency of the collisions that's increasing. So if you increase the concentration, there are more particles in the same volume, but it's a higher collision frequency, so it's more collisions in the same time. So again, pause this, have a look, make sure you know the different ways of measuring the rate, make sure you're sure about collision theory and how we actually measure the rate, and then all of these explanations. They're talking a lot about ethics now, so make sure you know what ethical reasons, what we mean by that. So for example, there was one about iodine here, and it was saying give one ethical reason why a compound of iodine shouldn't be added to sodium chloride, even though it says that we should have more iodine in our diet. And it's not really about things being harmful here. It's about people having the right to choose, or maybe there's insufficient evidence of the effect that it has on people, or it might be that some people need more than others. So that's different to, for example, religious reasons or cost or allergies. And also, they're asking a lot about instrumental methods, and remember you can change the apparatus as well as kind of changing the chemicals or whatever that's being used. And so what we've got here, this was a question in your mock, and here what they were looking for was things like the fact that you can insulate this. We're measuring a temperature change, so if you insulate the beaker, it's going to be much more, it's going to be much better